how much one quantity changes with respect to another quantity. Okay, so how much does it change? And so if you notice, we defined the rate of change as the change in y divided by the change in x. Make sure you get that down. That's not a typo. Change in y is on the top. Change in x is on the bottom. Okay, so make sure you get that down. Change in y over change in x. So we're going to go ahead and look at an example, and it says use the table to find the rate of change. Okay, use the table to find the rate of change. Explain the meaning of your answer. So now, I want to find the change in y divided by the change in x. So I'm going to pick two specific values in the y column, and I'm going to pick these two columns. Okay? And I'm going to pick the corresponding values in the x column. And so according to the rate of change formula, the rate of change equals the change in y over the change in x, right? So the change in y will be 156 minus 78. So notice what I did. I took this one minus this one. And I'm going to divide that by this one minus this one. So in that case, I'm going to divide it by 4 minus 2. All I need to do now is calculate that. What is 156 minus 78? (156 minus 78), what is that? 78. And I'm going to divide that by 4 minus 2, which is what? 2. So now we need to calculate what is 78 divided by 2. 39. So my rate of change in that problem is 39. Okay, now explain the meaning of your answer. Let's look. Number of computer games and the total cost. So what do you think that 39 means?
For every 2 games, it's $39.
For every 2. How about every 1? So in other words, each computer game costs $39. Okay, and that should make sense because notice the difference in change from 2 to 4, it goes up $78. So if I have 3 in here, okay, 3 is going to be halfway in between that, which will actually be, in this case, 117. So it would have increased $39. All right, real quick, I want you to find this one for me. Okay, the table shows how the tiled surface area changes with the number of floor tiles. Find the rate of change. So find the rate of change. Answer 16. Nice job. And I'm thinking that the 116 probably just hit the 1 a couple times. So it looks like you've got that down. Now you can pick any two values. It generally works to pick the first two. So you should have had 96 minus 48 over 6 minus 3. And like I said, from the looks of things, it looks like you got that down. So we've got two more things to talk about. And so first of all, for a function to be linear, the rate of change must stay constant. Okay, so for a function to be linear, the rate of change must stay constant. So we're going to determine whether this function is linear. So this is what we're going to do. I'm going to look at my change in y for my first two. What does the change in y do here? Add 4. What does the change in x do here? I add 1. Now that's kind of a little bit hard to understand with the negatives, but I do go up 1 in that case. So now I'm going to do the same thing with this two rows. What is the rate of change there? Or not rate of change, what's the change in y? Add 4. What do I do here? Add 1. So right now it's looking like it's going to work. Okay, but we need to check every row. So let's check this one here. What do I do? Add 4. What do I do here? Add 2. Is that rate of change the same? No. And so as a result, is this function linear? Nope. You need to check every set of pairs, or every pair of numbers. So all you're doing is you're checking the y's and combining them with the x's. So with that in mind, I want you to determine whether that function is linear. Okay, so go through and do the exact same thing we did in class. So is this function linear? Yes or no? The answer is yes. Nice job. Okay, you should have seen that every time I'm increasing by, in this case, 5, and I'm decreasing by 3. Okay, so every time that's what we're doing. So since that's the case every time, that's going to be a constant rate of change. All right, so with that in mind, this is what you need to do, pages 177 through 178, 14 through 23. Now, if you remember what I said, we're splitting this section into two parts. Okay, so tomorrow, we'll continue with the rate of change. Okay, we're going to talk about something known as slope.